Hello and welcome to our sixth and final lesson on quadratic functions. Today we're going to be solving problems using quadratic functions. Here's our first example. We've got a quadratic function passes through the point 316 and the zeros or x-intercepts are at 1 and 7. So there are my x-intercepts at 1 and 7. And then 316 is going to be there. We also know that our axis of symmetry is going to go through 4, or is x equals 4, because that's halfway between 1 and 7. So it looks like our parabola is going to go like that. If our axis of symmetry goes through 4, we know the equation is going to be y equals a x minus 4 squared plus q. So we don't know how high up it's going to go, and we don't know what the vertical stretch is going to be, but we do know that if we have x minus 4, then 0 squared will be when x equals 4. Okay, and now let's put in some of the information we know. So first we've got our point 316. And we also have our two intercepts. So let's use 1, 0 as our other point. So that can be rearranged to 16 equals 3 minus 4 is negative 1 squared is 1. So a plus q. And then we'll get 0 equals 1 minus 4 is negative 3 squared is 9. 9a plus q. Alright, and let's do substitution. So I'm going to subtract 9a from both sides here. So that'll give me q equals negative 9a. And now let's move way over here. So I'm going to substitute that into my first equation. So I'll get 16 equals a plus negative 9a. Or 16 equals a, equals negative 8a over negative 8. So a is going to equal negative 2. And then q equals negative 9 times a. So we'll throw in the negative 2 there. Q equals 18. So that means we've got y equals negative 2 x minus 4 squared plus 18. And let's just go back to our diagram, make sure this makes sense. So that would mean our vertex would be 4, 18, which looks right. And we're going to be opening down because of the negative, which we are. And normally we'd go over 1, down 1. But because it's negative 2, we go over 1, down 2. Gets us to 316. So yeah, everything looks good. Okay, question 2, we've got a bridge. Spans a horizontal distance of 40 meters. Has a parabolic arch. So that means it's going to be a quadratic function. And 1 meter from the end of the bridge, the arch is 1.95 meters high. Okay, so, get my pen here. Just for ease sake, I'm going to say that this is the length of my bridge from 0 to 40. I could put it anywhere, but it just makes it easier. Which means that at 1, we're going to be at 1.95 meters high. And also at 39, we're going to be at 1.95 meters high. And there is our parabolic bridge, drawn poorly by me. Okay, and again, we know our axis of symmetry is going to be at 20 So that's the line x equals 20. So we can do the exact same thing as on the last page. We get y equals a x minus 20 to get our axis of symmetry in the right spot, plus q. And now let's just choose 2 points. 0, 0 would be a nice easy one to use. And the other one, we can use is 1.95. So y equals 1.95. And that is a terrible q. All right, so let's move down over here. So we end up with 0 equals negative 20 squared is 400a. And we've got 1.95 equals 1 minus 20 is negative 19. Square that, we get 361a plus q. And same as on the last page, I'm going to use substitution, so I'm going to subtract 400a from both sides on the top one. And that's going to leave me with negative 400a equals q. Substitute it into there. So I get 1.95 equals negative 39a. Get myself a little space here. Divide by negative 39. I get a equals negative 0.05. Notice the question gave us decimals, so I'm going to allow you guys to work in decimals on this one. Okay, swing her back up here, and we'll throw that into that equation. So we've got a equals negative 0.05. Multiply that by 400, and we get q equals $20. So our equation is y equals negative 0.05 x minus 20 squared plus 20. So our vertex up here is going to be 2020. And it's going to be really spread out. It's going to be really vertically compressed, which is going to make it look like it's stretched left to right. And obviously we're opening down because of the negative. Question B, how high is the center of the arch? Well, if our vertex is 2020, then it's 20 meters high. Okay, number 3. I got two numbers, have a sum of 20. That means they add together to give us 20. And then we're going to talk about the sum of their squares. Okay, so first thing we need to do is define our variables. So we'll say x is one of the numbers, y is, I'm going to use z here. Z is the other number, and we'll go y is the sum of the squares. The reason I did that is it's easier to make y equal whatever you're trying to maximize or minimize. So in this case, we're trying to maximize or minimize the sum of the squares, so that's our y. Okay, so it says the two numbers add to 20. The sum is 20, so x plus z is going to equal 20. And then the sum of the squares So there's one square, there's the other square, and the sum is those two added together. Okay, and again, we're going to have to use substitution. So I'm going to subtract x from both sides up here, and that's going to give me z equals 20 minus x. And I'm going to sub that into that equation right here. So I get y equals x squared plus 20 minus x squared. And of course, 20 minus x squared is 20 minus x times 20 minus x. There we go. Collect like terms. Oops. Okay, and now we've got a 2 in front of here, so we need to get rid of that before we can complete the square. Start up here again, so we get y over 2 equals x squared. Oops, and I should leave a space there with my plus 200. Save a line. So y over 2 is going to equal x minus 10. So that's going to be plus 100 minus 100. So that's plus 100. And now multiply both sides by 2. So just a rough sketch here. We're going to have a vertex at 10, 200, and we're going to be opening up. So the smallest the sum of the squares can possibly be is 200 when x, the first number, is 10. So if x equals 10, then if they add to 20, the second number must also be 10. So we have a minimum of 200 when the numbers are 10 and 10. And that is the worst attempt at writing the word "and" I've ever seen in my life. And question 4, our final question. Okay, we've got 100 meters of fence to make a rectangular pen, and we want to maximize the area. So right away, let's make y equal the area, because that's what we want to maximize. And there's our pen, and let's call that side x and that side z. That's good enough for defining our variables. Area equals length times width. So in this case, it's going to be x times z. And we also know we've got 100 meters of fence. So that means that 100 is going to be 2 x's and 2 z's. All right, and again, let's use substitution. And divide both sides by 2 first. And then subtract x from both sides. Perfect. Now I'll just substitute that into my area equation. Rainbow that in. And now let's rewrite this so it's a bit more familiar. Start again up here, save some space. And we can even put on a plus 0 if that makes us feel more comfortable. Okay, let's get rid of that negative by dividing both sides by -1. I'll put my plus 0 way over there. So that's going to be x minus 25 squared, so that's going to be plus 625 minus 625 up there. And I'm going to have minus 625 there. Multiply both sides by -1 to get y by itself. That was supposed to be a 5. Alright, so let's have a look here. So we're going to have vertex at 25, 625, and we're going to be opening down because of the negative. So we're going to have a max of y equals 625 at x equals 25. Okay. A lot of people are tempted to say that this is a 25 meter by 625 meter box, which makes absolutely no sense if we only have 100 meters of fence. So let's look a little closer here. Y is our area. So we're going to have a max area of 625 meters squared when x is 25 meters. If I've used up 50 of my 100, that means I got 50 left. So these are also going to be 25 meters for x. Quick double check, 25 times 25 is 625, so that works. And notice that a square is a special case of a rectangle. And if I'd have just told you it was a square at the start, it wouldn't even be a question.